I am here to give you a quick bite for the highlights of the transport layer of the Internet, TCP and UDP. Then next is the application layer of the Internet.
What is transport layer? The transport layer provides a reliable mechanism for the exchange of data between processes in different computers. There are two protocols of transport layer in the Internet, the Transmission Control Protocol and the User Datagram Protocol. Let's start with Transmission Control Protocol. TCP is the connection-oriented transport layer protocol described in RFC 793. TCP ensures that the data reaches intended destination in the same order it was sent. It aims to provide a reliable end-to-end byte stream between two hosts in an unreliable network. There is two characteristics of a TCP connection. Full duplex, meaning communication can go through both directions simultaneously. Point-to-point, meaning there is exactly two endpoints. An application can connect to a remote application through sockets, whose socket number is composed of the remote station's IP address and the destination application's port numbers. Here's the frequently used TCP port numbers. Now, let's take a look at the TCP segment header. The source port is the process port number of the originating station, while the destination port is the process port number in the receiving station. The sequence number is an assigned number to a TCP packet indicating its beginning byte number. The acknowledgement indicates the next sequence number expected by the destination station. The data offset indicates the start of the data field in the segment measured in 32-bit words. The reserved bits were saved for the future use. It must be set 0 if not in use. The control units are the following flags. URG means urgent pointer, ACK means packet contains acknowledgement, PSH means push function, RST means resets the connection or denies connection request, SYN means synchronized sequence number. It is used to establish the connection, while the FIN used to release a connection. The window tells how many bytes may be sent starting with 1 indicated at the acknowledge field. Checksum is used to verify the correctness of the TCP segment. Urgent pointer points the sequence number of the byte following the urgent data, while the option fields allow TCP to operate with additional options not covered by the regular header. The connection establishment in TCP. Before any data is sent, processes at the application layer must issue function calls to TCP in order to establish a connection. Examples of function calls or primitives are open, close, send, receive, and status. To establish the connection, the client and the server performs the three-way handshake with purpose of synchronizing their sequence numbers and acknowledgement numbers. Here's an example of the three-way handshake used in establishing a TCP connection. We have a client A and server. The client A will send synchronized sequence number of 200. When the server receives the request, server will insert its own sequence number, say it's 550, and place 201 in the acknowledged number field. Client A will receive this response and know that it is the server's answer to its previous connection request. Client A will then send a new packet having the acknowledgement bit field set. The sequence number is equal to 201 and the acknowledgement number field is 551. How did we set the value of sequence numbers and acknowledgements? The destination station must acknowledge the data received. The acknowledgement number is calculated using this formula. ACK number is equal to sequence number plus good bytes width in the segment. For TCP, the sequence number is incremented by 1 for each byte to be transmitted by the TCP entity. Like we have an example with sequence number of 200 plus 1 byte will be 201 on acknowledgement. In different scenario, if the sequence number of 50 sent a packet containing 5 data bytes, it will increment its next sequence number to 55. Always remember that the sequence number is set to the number of the first byte being sent. The connection termination is accomplished by utilizing the FIN bit in the TCP header. For example, the application running at the client A sends a packet to a server with the FIN bit set. The server will then acknowledge the packet and it will now no longer accept data from client A. Since TCP is full duplex, the server will also send a packet with the FIN bit set. Upon receiving the request for connection termination, client A will then reply with an acknowledgement to finally close the connection. The next topic is about User Datagram Protocol. User Datagram Protocol is a connectionless transport protocol and it is described in RFC 768. It is a very simple and fast protocol. It is a good protocol for data flowing in one direction but does not guarantee order delivery of data, which makes it unreliable. UDP is used when speed is desirable and error correction isn't necessary. For example, UDP is frequently used for live broadcasts like video streaming and online games. Now that you know the UDP, let's look now at the UDP header. The source port is the process port number of the originating station, while the destination port is the process port number in the receiving station. This port will depend on what program we're going to run. For example, if we are running DNS, the destination port will be 53, while if we're using trivial file transfer program, the port will be 69. The length field indicates the length of the header and the data in terms of bytes, while the checksum used to check the validity of the header and the data. In general, transport layer is the first one which breaks the information data supplied by application layer into smaller units called segments. This layer provides end-to-end delivery of data between hosts which may or may not belong to the same subnet. All server processes intend to communicate over the network are equipped with well-known transport service access points, also known as port numbers. The protocols on this layer are TCP for connection-oriented and UDP for connection-less. The last topic of this discussion is about the application layer of the Internet. In this layer, the network's usefulness is really obvious from the point of view of end users because of its applications. Application is another term for a program that performs a function directly for a user. This layer will explain 5 popular Internet applications or programs. Let's start with domain name system. DNS is a general-purpose data query system that allows any program or users to look up an IP address of a domain name or station. DNS is a support program that is used by other applications. Application sends a query to the DNS asking for the numeric IP address of a machine on the Internet given its domain name. Domain names are hierarchical, indicating the host country, LTD category, and host or machine name. Let's look at the DNS namespace that is organized in a hierarchical manner. On the top of it all is the dot pronounced as the root. Under root, there are 2 types of top-level domains, the country and generic. Countries include the likes of PH for Philippines, JP for Japan, US for USA, CH for Switzerland, and ZA for South Africa as defined in ISO 3166. Generic domains are those with com for commercial establishments, edu for educational institutions, or org for organizations. Here's the common top-level domains and their meanings. A dot or period separates the components. Domain names are case-insensitive and can be up to 63 characters long. For example, for Apple Computers Incorporated in the USA, NIC will assign apple.com as its domain name. The rest of the domain name, like the host name, will be assigned by Apple's network administrator. Thus, if the company names its World Wide Web server computer as www, the most probable domain name of the server is www.apple.com. The second application is Telnet, a remote terminal connection protocol. Telnet allows users to log into a remote terminal and work as if he is in front of it. To do this, Telnet uses an imaginary terminal as the standard terminal. All other terminals are mapped into this imaginary terminal standard. The Telnet program is involved with or without an argument, which could be a domain name or an IP address. Without the argument, Telnet will have to wait for the user to open a connection. The Telnet application would start to establish a connection to the remote device. During the connection attempt, the source and destination station communicates options like: first, which side will echo characters. Second, specify what terminal type to use. Third, set a timing mark to synchronize both ends of the connection. Fourth, set a line mode so that a string of characters may be sent instead of one character at a time. And last, request the status of a Telnet option from the remote terminal. The third is World Wide Web or WWW. It is a distributed information system that uses hyperlinks. Users can gain information by browsing through pages that contains images, text, tables, and hyperlinks to other documents or pages. With a browser, the users can get access to other internet applications like FTP, Telnet, etc. The protocol used for the exchange of hypertext is HTTP. Pages are written using HTML. Pages are named or located using URLs. If browsers run on a client side, a process called HTTP server runs on the server side. This process listens to TCP port 80 for connection requests from clients. Once a connection is established, the client can now send a request and the server can reply. This rule of transaction between the client and the server should adhere to HTTP or the Hypertext Transfer Protocol. In a step-by-step fashion, the transaction goes this way. First, the browser gets the chosen or clicked URL. Next, the browser inquires about the IP address of the target server based on the URL from a domain name server. Third, the DNS server replies with an IP address. Fourth, the browser sends a connection request to TCP port 80 on the target server identified by the IP address returned by the DNS server. Fifth, the client sends a request for the desired page file. Next, the server sends the file and then the server closes the connection. 8. The browser interprets the page document and displays it according to the formatting specified in the page. Last, the browser fetches and displays all text and images in the page file. For every page on the www, there are 3 things which identify it. First, what is its name? Second, where it is located? And third, how it is accessed. The solution to these questions are answered by a Uniform Resource Locator or URL, which gives a web page a unique worldwide name. It has 3 parts. The first part answers the third question, and that part is called the protocol name. The second part of URL answers the second question, and it is called the DNS name. The last part of a URL is the file name, and it answers the first question. For example, we have http://www.cs.columbia.edu/network.index.html. The protocol name will have the HTTP, the domain name will have the www.cs.columbia.edu, then the path and file name will have the network/index.html. HTML stands for Hypertext Markup Language, is the language used to describe how a document or a web page should be formatted when displayed. It is not a programming language. Markup files contains explicit formatting commands called tags. In HTML, for example, this command marks the start of boldface which ends with this command. Almost every command is a pair of starting and ending format specifications or tags. All the browser has to do is to understand the markup language. FTP, which stands for File Transfer Protocol, is an application that allows the transfer of files from station to station using the network. Both files of binary and text types can be downloaded or uploaded depending on the level or permission a user has. The last but not the least application tackled in this module is email or electronic mail. Emails are composed of 2 subsystems, the user agent and transfer agent. The user agent is the program used by the user to read, compose, send, save, and retrieve the mail. The transfer agent, on the other hand, is responsible for the delivery of mail from the originating machine to the destination machine, usually without the user's intervention. There are 5 basic operations in an email system. First is composition, second is transfer, third is reporting, fourth is displaying, and last is disposition. In the Internet, the message is transferred by the source machine connecting to TCP port 25 of the destination machine. The daemon on the destination speaks the SMTP or Simple Mail Transfer Protocol conventions. A simple protocol which can be used for fetching mail from mail server is POP3 or Post Office Protocol. It allows the users to log in, fetch messages, delete them, and log out. If you have an internet service provider account, this is most likely the protocol your email program is using to fetch your email from the mail server. If the user uses several computers to access his mails, another protocol, which is IMAP or Interactive Mail Access Protocol, can be used to manage a central repository accessible from other machines. An email server functions as the central repository. Unlike POP3, IMAP does not copy emails on the user's machine. The emails remain intact at the central repository.
And that wraps our discussion for today. Thank you for your time and have a nice day.